So today we will go over a quick summary of collisions. So what is a collision? So a collision is any interaction where two or more objects exert forces on each other for a short time. So basically is it doesn't have to be like objects hitting each other in terms of the conventional sense when we think of collisions. It's not just crashing. So it can be when planets like gravitational slingshot, when you feel large amounts of gravity in short periods, in a short amount of time, that could also be a collision. So basically all of those are collisions. So how do we do collisions in physics? Well, as in a lot of areas in physics, you want to start solving problems by using conservation rules. So the first one we know, the first conservation rule we have is the conservation of momentum, which states that the momentum before will equal to the momentum after. So P1 can be written as M1 times velocity of object 1, which is momentum. Momentum is P equals mv. Momentum equals mass times velocity. And then mass of object 2 times velocity of object 2. So that's the initial momentum. And then the final momentum will equal mass of object 1 because the mass doesn't change. The velocity can change though, times the velocity of object 1. I'll say final 1f plus mass of object 2 times velocity of object 2 final. So that's kind of how you use the conservation of momentum in solving problems. And of course sometimes you can also use the conservation of energy, which is kind of similar to the conservation of momentum, but the conservation of energy basically says that the energy before equals to the energy after. So you could separate energy 1 to be like kinetic energy plus potential energy equals kinetic energy after plus potential energy after. And another quantity you might want to know for collisions is the impulse. The impulse is J. So J is used to represent the impulse. The impulse is defined as the change in momentum. It can also be written as the total force times change in time. And if you want an integral form, it can be the integral of T1, T2 to T1 of F dt. So basically, impulse is kind of like the measure of like force over time in that sense, like how much force in a specific amount of time. And it can be calculated using the change in momentum. So there are like basically two types of collisions, basically. So there are two types of collisions. The first one is elastic collisions. In elastic collisions, momentum is conserved as all collisions in a closed system. But in elastic collisions, the kinetic energy, the Ke, is also conserved. So that means basically the kinetic energy before M1 let's just say, I'll write U now, actually. Remember, the kinetic energy is basically equals 1 over 2 mv squared, basically. I use the symbol U to represent the initial velocity, and I'll use V to represent the final velocity. So that is the conservation of kinetic energy in elastic collisions. So examples of elastic collisions are like atomic or molecular collisions, and in general, elastic collisions. The second type of collisions is inelastic collisions. So in inelastic collisions, momentum is conserved too, because the law of the conservation of momentum is always conserved in a closed system, but the kinetic energy is not conserved. So the energy is lost as like heat, sound, or deformation. In the ideal case, like a perfectly inelastic collisions, the object will stick together after the collision, because this will like allow the maximum kinetic energy loss case. So then in that case, it can be calculated as V equals m1 u1 plus m2 u2 over m1 plus m2. As you can see, this is similar to the center of mass, like the velocity of the center of mass formula. So those are basically the two main types of collisions: elastic collisions and inelastic collisions. Mostly in problems you will do with elastic collisions because it is easier. So now, some other quantities you might want to know is the coefficient of resolution, which is represented by the symbol E. So basically, the symbol E, the coefficient of restitution, my bad. The coefficient of restitution measures how bouncy a collision is. So E is the relative speed after over the relative speed before. So if E equals 1, it'll be perfectly elastic. If it's between 0 and 1, it'll be inelastic, which most collisions are. And if E equals 0, it'll be perfect inelastic, which is the case I talked about when the objects have the same velocity and stick together. So in 1D collisions, you just basically use like the conservation laws. In elastic collisions, you'll have the conservation of kinetic energy too, but usually you have the conservation of momentum too. So using those two equations, you manipulate your way through variables using algebra, and you can solve. In 2D collisions, as in most of physics, momentum will be conserved in both directions. So you have to basically split it into two parts. You're going to have, in 2D, you're going to have that total momentum in the x is constant, and total momentum in the y is also constant. So yeah, you're gonna have to split it into components like Vx equals V cos theta, and Vy equals V sine theta. And basically, that's just about it for collisions. Thank you.